example number 8 says, suppose that we have a bus and that it is at position y sub I. So its position from wherever the starting point is, its position yi at some time ti, where I ranges from 0 all the way up to n. Okay? And so, for example, let me just say this. Let's say I is equal to 0. Then it has a position at a position 0, okay, and it travels for that, and that position at 0 occurs at time 0. So if I was equal to 1, then I have y1 and t1. What this means is this is the position of the bus at time 1. Okay? Now, its velocity, its average velocity, would be given by the change in position divided by the change in time. Now, the book says for this problem that we should assume the velocity is constant. So what it means is that the average velocity is equal to the instantaneous velocity over that interval. So equal to the instantaneous velocity on that time interval. Okay? So now we're supposed to use a telescoping sum to confirm that the distance traveled equals the difference between the final and the initial position. So what do we know? Well, we know that the total distance is equal to the sum, okay, when I is going to go here from 0 to n of the velocity times the change in time. Well, what is velocity? Our velocity is constant. And so this says that we've got the following. Velocity should be equal to yi plus 1, depending on where we're going to start. Okay, so let me start this way. Instead of starting at 0, let's start when I is 1. Okay? And so what we'll do is we'll say this minus this. It's just a notation thing. It doesn't matter which way we do this. Over this minus, okay? So let's just check. The change in distance from I equals 1 to 1. So basically, the change from this is really from 0, even though I'm starting the count at 1, it's really from 0 to 1. Okay, because watch what gets put in here. I'm not done with this, by the way, yet. This has got to still be multiplied by the change in the TI, and the change in the TI is equal to TI minus TI minus 1, like that. That is the change velocity times the amount of time that you take to do that is your change in your distance. And so if we just went from 1 to 1, what we get here is we would get y1 minus y0 over t1 minus t0 times t1 minus t0. And that would only happen once. I shouldn't have put the sum here because bad notation. If you went from 1 to 1, this is what you would get out. Okay. And then this would be equal to y1 minus y0, your end position minus your initial position. Now let's check the change in distance when we go from I equals 1 to 2 of yi minus yi minus 1 over ti minus ti minus 1 times ti minus ti minus 1. Okay. Now, of course, this reduces, right? We can cancel this with this, so we can cancel this with this. So watch what happens when I plug in 2 here. Okay, so this is equal to I goes from 1 to 2 of yi minus 1. When I plug in 2, I start at 1. So it's going to go y1 minus y0 plus y2 minus y1. And so these guys are going to cancel. I'm going to be left with y2 minus y0. End position minus initial position is you're changing your distance. Okay. So in general, our change in our distance. So the overall change in distance is going to be equal to the following. It'll be the sum. I goes from 1 to n, wherever we end up, okay, of yi minus 1. And so that will give me y1 minus y0 plus y2 minus y1 plus y3 minus y2 plus, and then down to the end will be yn minus 1. And so, of course, this guy cancels with this guy cancels with this guy, and this guy cancels with the guy in here, but then there's another guy in here that cancels with this guy. So I'm left with yn minus y0. And so what this says is that the amount of distance that I travel is equal to my end position minus my initial position. And that's it.